5.9 billion kilometres from the Sun. At the far edge of everything we call home, there is a small world that should be dead. Everything we knew said so. It is tiny, 2,377 kilometres across, smaller than our own moon. It sits so far out that sunlight arrives 900 times fainter than it does on Earth. Noon there looks like a deep blue twilight. The temperature at the surface holds near minus 230 degrees Celsius, cold enough to freeze nitrogen straight out of the air and lay it down as solid ground. It has no giant neighbour squeezing it, no tide to knead it warm, no real source of heat except the fading memory of its own formation. By every model we had, a body that small, that cold, that starved of energy should have gone quiet billions of years ago, frozen to its core, geologically inert. A leftover chip of ice and rock drifting in the dark, doing nothing at all. That is the version of Pluto most people still carry in their heads. The one that got demoted in 2006, dropped from the textbooks, turned into a punchline. The planet that wasn't. And then, in 2015, we finally went to look. What we found did not match the story at all. The world that was supposed to be dead turned out to be one of the most restless, most active, most quietly alive places we have ever seen. Both things are true at once. Pluto has almost no energy to spare, and Pluto will not sit still. How is that possible? And if it is true of Pluto, what does it mean for the thousands of frozen worlds beyond it that we have already written off? To understand how Pluto broke its own obituary, you have to start with the man who found it, and the spacecraft that carried a piece of him back. A young astronomer named Clyde Tombaugh discovered Pluto in 1930, a faint dot shifting against the stars. For most of the century that followed, that dot was almost all we had. Pluto was too small and too far to resolve into anything more than a smudge, even for our best telescopes. So we filled the gap with assumptions, and the assumptions were bleak. Small, cold, dead. New Horizons launched in 2006, the same year the world decided Pluto was no longer a planet, carrying among its instruments a small container of Tombaugh's ashes. It flew for 9.5 years to get there, and it could not slow down. It could not stop, could not orbit, could not turn around. It had one pass, a few hours, moving at nearly 50,000 kilometres an hour, closing to within 12,500 kilometres of the surface, to gather everything it could. Then it kept going, out into the dark, and spent the next 16 months whispering its data home across 5 billion kilometres of empty space. There was no margin in any of it. At that speed, a single fleck of debris could have ended the mission in an instant, and there was no way to steer around what no one could see. Even its radio signals, travelling at the speed of light, took more than 4 hours to cross the gap. So mission control could only wait, blind, while 9 years of flight and a lifetime of work by many of them rode on one uninterrupted afternoon. And piece by piece, as those images came down, the old Pluto fell apart. The first thing that stopped people was the heart. A vast, pale plain, roughly the size of Texas, sitting inside what looked like an ancient impact basin. From a distance it seemed smooth, almost blank. And that was the first problem. because a surface that smooth in a place that old meant something was actively wiping the craters away. Out here, everything is supposed to be scarred. 4 billion years of impacts leave their marks. This plain had almost none. It looked less than 10 million years old. On the clock the solar system keeps, that is this morning. The whole heart-shaped region was later named Tombau Regio, a quiet tribute to the man whose ashes were riding past it aboard the spacecraft. Its bright western lobe, the plain itself, is called Sputnik Planitia, and it spans roughly 1,000 kilometres, the largest known glacier in the solar system. And when the sharper images arrived, the smoothness turned out to be a lie. The surface was broken into great irregular cells, tens of kilometres wide, edged by shallow troughs, like the skin that forms on cooling porridge. Those cells are not cracks, they are convection. The nitrogen ice is slowly turning itself over, warmer ice rising in the middle of each cell, spreading outward, cooling, sinking back down along the edges. One full cycle, roughly every 500,000 years. On a world that was supposed to be frozen solid, the ground is moving. Which raises the only question that really matters. Where is the heat coming from? Pluto has no tidal heating. It is not being flexed and kneaded by a giant planet the way Europa is worked by Jupiter or Enceladus by Saturn. It has no meaningful sunlight. The only thing left is heat from inside. The slow, radioactive decay of elements locked in its rocky core, left over from the day it formed. But Pluto is small. A body that size should have bled that warmth into space long ago. The arithmetic simply does not close. And yet, the moving ice is right there in the pictures, doing the thing the arithmetic says it cannot. And the plain was only the beginning. New Horizons found mountains, ranges of them, some rising 3,500 meters above the ground around them. Not mountains of rock. Out here, at these temperatures, ordinary water ice is not soft or slick. It is as hard as granite, and it behaves like stone. These were mountains of frozen water, with sharp crests and clean faces, the look of things that formed recently and have not had time to wear down. Something pushed them up. Something was still building landscape on a world that, by the textbook, gave up building anything 4 billion years ago. Then there were the glaciers. Not water glaciers, nitrogen glaciers. Frozen rivers of solid nitrogen that creep down out of the highlands and pool into the Great Plain, carving channels, leaving flow lines, moving the way ice moves on Earth. Too slowly to watch, but unmistakably. At a temperature that would freeze the oxygen out of your breath and lay it on the ground as frost, Pluto is running an active glacial system, resurfacing itself, erasing its own history. Sit with that for a moment. We struggle to keep a road intact through a single hard winter. Pluto is quietly repaving an entire world in conditions that would turn the air itself to stone. And then there are the volcanoes. In the southern hemisphere, New Horizons found two enormous features, Wright Mons and Picard Mons, each a broad mountain with a deep hollow at its summit, the unmistakable shape of a caldera. Wright Mons alone stands around 4 kilometres tall and 150 kilometres wide. If it truly is a volcano, it is among the largest of its kind found anywhere in the solar system. And it was raised in the cold and the dark by a world that was not supposed to have the energy to build anything. But a volcano out here does not erupt molten rock. It erupts cold, a slurry of water ice, ammonia, nitrogen and methane, pushed up from somewhere below and frozen almost the instant it reaches the surface. Cryovolcanism. The ground around these mountains carries almost no craters, which means it was resurfaced recently. And more recently still, researchers taking a second look at a crater called Kiladze concluded that it too had been flooded with ice lava, that it had been, in their words, alive only a few million years ago. Picture standing there. No lava, no heat you could feel, total darkness, snow crunching underfoot, and above you a mountain that once vomited ice into a sky so cold the eruption froze before it could flow. It is one of the strangest landscapes we have ever documented, and we found it on the world most people had already stopped thinking about. Pluto has an atmosphere too. By its size and its gravity, it should not be able to hold one, but it does. A thin envelope of nitrogen, methane and carbon monoxide, reaching up to 1,800 kilometres above the surface. When New Horizons looked back with the sun behind Pluto, that atmosphere lit up in dozens of separate layers of soft blue haze, stacked one on top of another like the rings inside a tree. The blue comes from tholins, complex organic molecules built when ultraviolet light shatters the methane and nitrogen high in the atmosphere, and the broken fragments knit themselves back together into something larger. Those tholins drift down and stain the surface a deep reddish brown. The rusty colour you see in every photograph of Pluto is not rock. It is organic chemistry raining slowly out of the sky. And the atmosphere does not sit still. Pluto's orbit is long and lopsided, 248 years to circle the Sun once, swinging closer and then far away. As it nears the Sun, surface ice turns straight to gas and the atmosphere thickens. As it retreats, that same atmosphere freezes and settles back onto the ground. Pluto is breathing, drawing in and letting out its own sky on a cycle that takes 2.5 centuries to complete. Stand on the near side of Pluto and the view would be unlike anywhere else we know. The Sun would be a single fierce star, bright enough to throw a shadow, far too small to warm you. And Charon, Pluto's great moon, would hang in that sky enormous and utterly still, never rising, never setting, fixed to the same patch of black, because the two worlds are locked forever face to face. From the far hemisphere, you would never see it at all. For a long time, we assumed that haze was merely cosmetic, a stain on the picture, Newer eyes have changed the story. In 2025, the James Webb Space Telescope managed to separate Pluto's heat signature from Charon's for the first time, and found the haze is not decoration at all. Those organic particles, much like the ones that shroud Titan, largely control the temperature of the whole atmosphere. The smog runs the thermostat. Even the air on Pluto is doing something we did not expect. And that thin, breathing air builds dunes. New Horizons found long ridges of methane ice grains lined up with the prevailing winds. Dunes on a world where the atmosphere is 100,000 times thinner than ours, far too weak to lift anything on its own. The grains, it turned out, are not thrown up by wind at all. They are kicked into the air by sublimation, ice flashing to gas in the faint sunlight, nudging particles upward where the thin breeze can carry them and lay them down again. An entirely new way to build a dune, one nobody had seen or even proposed until Pluto showed it to us. Every one of these discoveries forced the same uncomfortable question, not only about Pluto, but about everything like it. Pluto is a Kuiper Belt object, one of hundreds of thousands of icy worlds drifting in a vast ring of debris beyond Neptune. The belt reaches from Neptune's orbit out to 50 times the distance between the Earth and the Sun, and further still. A frontier so large that everything we have ever studied closely within it could fit inside a rounding error. For almost the entire history of planetary science, we assumed that ring was uniform and dead, cold rubble left over from the building of the solar system and nothing more. Pluto was meant to be the largest piece of that rubble, and none of it was supposed to be interesting. If the biggest object in the belt turned out to be this complex, this active, this alive, what about the rest of them? What about Eris, very nearly Pluto's twin, orbiting even further out? What about Makemake, or Haumea, or Sedna, drifting through an 11,000-year loop at the fringe of everything? We have almost no close-up data on any of them. We assumed they were boring. But we had never actually looked. Pluto also quietly demolished one of the oldest assumptions in the field, that size decides complexity. The rule of thumb was simple. Big worlds do interesting things. Small worlds cool off, freeze, and stop. And by that rule, Pluto should have been the deadest of the lot. Mars is larger, and Mars went quiet long ago. Mercury is larger, and it is cold and still. Our own moon is larger, and it is dead. Pluto, smaller than all of them, is the one still actively reshaping itself. It is more geologically alive right now than worlds 10 times its mass. It did not just break its own story, it broke the rule we had used to write everyone else's. And then there is Charon. Pluto's largest moon is enormous relative to Pluto itself, over half its width. The two do not orbit the way the moon orbits Earth, with a small body circling a large one. They turn around a shared point that sits in the empty space between them, like two dancers holding hands, each keeping the same face permanently toward the other. Some scientists refuse to call Charon a moon at all. They call it a binary partner, a double world. Charon had its own surprises waiting. A canyon system tears across its equator, in places running more than 5 times deeper than the Grand Canyon. That belt of chasms is itself a clue. Charon, too, seems to have held a subsurface ocean once, one that froze solid long ago and cracked the moon's crust as it expanded. A smaller echo of the sea that may still survive inside Pluto. And its north pole is capped in a dark reddish stain that researchers informally named Mordor macula. The leading explanation is a strange one. Methane escaping from Pluto's atmosphere drifts across the gap, freezes onto Charon's cold pole, and is slowly processed by ultraviolet light into the same tholins that redden Pluto itself. Pluto is painting its own moon with its breath. Here, too, new instruments have deepened the mystery. In 2024, the James Webb Space Telescope detected carbon dioxide and hydrogen peroxide on Charon's surface. The peroxide a sign that radiation is still actively splitting the water ice, chemistry unfolding on a moon we had assumed was long finished. 4 smaller moons complete the system: Nix, Hydra, Kerberos, and Styx, tumbling chaotically, spinning in ways that never quite repeat, because the gravity of the Pluto-Charon pair beneath them is itself always shifting. We did not even know they were there until the Hubble Space Telescope picked them out, one by one, in the years before the flyby. Proof of how much can still hide around a world we thought we had catalogued. To stand on one of them would be to look up at a sky that never behaves the same way twice. Take all of it. The convecting plains, the mountains, the glaciers, the ice volcanoes, the breathing atmosphere, the dunes, the painted moon. And add one more thing, the strangest of all. Beneath Pluto's frozen shell, there may be an ocean of liquid water. The evidence is indirect, but it lines up. Sputnik Planitia sits almost exactly on the line between Pluto and Charon, precisely where you would expect extra mass to gather, and a dense layer of liquid water beneath the ice would supply it. The surface is fractured in the pattern you would get if an ocean underneath had been slowly freezing and expanding over time. On the far side of Pluto, directly opposite the basin, New Horizons glimpsed a muddle of ridges and cracks. The kind of scar you would expect if the shock of the impact that made the heart had rung the whole world like a bell, focused by an ocean within. Run the models, and the best fit is a shell of ice 40 to 80 kilometres thick, floating on a hidden sea, one a little saltier and denser than Earth's own oceans. Dissolved ammonia, working as a kind of antifreeze, would help keep it from setting solid, while a lid of exotic ices above holds the warmth in. Salty enough that if you could somehow reach it, you would float. And the most recent work suggests this ocean is not a late arrival. It may have been there almost since the beginning, kept liquid for nearly the entire history of the solar system, insulated from the killing cold by a blanket of frozen gases sealing in the faint warmth of the core. An ocean in permanent darkness that has never seen sunlight, never felt the solar wind, sitting quietly beneath the ice since before anything was alive on Earth. That isolation is exactly what makes it interesting. We used to believe life needed sunlight, warmth, an Earth-like world. But on our own planet, we keep finding things that break those rules. Microbes thriving in total darkness around hydrothermal vents on the deep sea floor. Whole ecosystems running on chemical energy instead of light. If Pluto's ocean has a rocky floor, and if that floor is even slightly warm, then it holds the same basic ingredients: liquid water, mineral-rich rock, and an energy gradient. That is the same recipe we now chase at Europa and Enceladus, the ocean moons we already treat as our best odds for life beyond Earth. Pluto was never on that list. Quietly, on the evidence, it has begun to earn a place near it. Nobody is claiming there is life on Pluto. That would run far ahead of the evidence. But the fact that we can no longer flatly rule it out, on Pluto of all places, tells you how badly we misjudged this world. Which brings us back to the question the moving ice first asked: where does the heat come from? For years, there was no clean answer. In 2025, a new one arrived, and it reframes the whole system. The idea is that Pluto and Charon were born from a collision. Two icy worlds struck each other, but instead of shattering, they briefly stuck fast, turning as one, like a snowman spinning in space, and then separated again, staying bound in orbit. Kiss and capture, the researchers called it. And as the two bodies twisted apart, the friction of that separation poured heat deep into both of them. Enough, perhaps, to start an ocean, without needing Pluto to have formed in some hotter, more radioactive early age. The world that should have no heat may have been warmed by the very act that gave it its moon. It is worth being honest here. None of this is settled. The ocean is inferred, not seen. Some models published just as recently argue that Pluto's interior is solid after all. Kiss and capture is a fresh idea, not a proven one. We are watching scientists reason their way toward a world they have visited exactly once, for a few hours, a decade ago. Alan Stern, who led the New Horizons mission and never accepted Pluto's demotion, has spent years arguing that the definition used to exclude it was poorly built to begin with. Whether or not he is right about the word, the data from his spacecraft settled the only question that counts. Whatever you call Pluto, it is not simple. And it is absolutely not dead. There is already talk of going back. Not another flyby, an orbiter this time, something that could stay and watch Pluto change across its seasons instead of catching it in a single frantic afternoon. The concepts carry nuclear power sources, instruments to map the surface over years and to listen for the gravitational signature of that hidden ocean, to confirm it or rule it out for good. One proposal even has a name: Persephone. None of them are funded. The distances are staggering, and the travel time would be measured in decades, not years. A mission launched today might reach Pluto around the time a child born this year is finishing their working life. But consider what a single pass already did. We spent 76 years calling Pluto a planet, 9 more years arguing about whether it deserved the title, and, until 2015, almost no time at all understanding what it actually was. The argument over the name was always a distraction. Pluto does not care what we call it. It is out there right now, 5.9 billion kilometres away, doing things we cannot fully explain, on a world we met for a few hours and have not returned to since. And the most unsettling part is not any single discovery. It is the pattern. Every time we have sent a spacecraft to something small and cold and far away, something we were certain would be dull, it has turned out to be extraordinary. Enceladus, Titan, Triton, and now Pluto. Which means every other frozen world we have not yet visited, and there are thousands of them out past Neptune, could be hiding the same kind of complexity, waiting in the dark. New Horizons itself proved the point. 4 years after Pluto, in 2019, it slipped past a tiny, far more distant object called Arrokoth, the most remote world any spacecraft has ever visited. It turned out to be 2 soft lobes joined into a gentle snowman, a pristine relic from the solar system's first days, preserved untouched in the deep cold. Even that frozen splinter had a story to tell. We tend to think of the edge of the solar system as the empty part, the leftovers, the place where the map runs out. Pluto is the quiet proof that we had it backwards. We have barely looked, and the edge is already more alive than we ever dared to imagine.